Guys, you can hear me at the back? Yeah, perfect. Cool. Wow, this is a big room and a big audience. So, good afternoon, everyone. This is Mohit. So, let me start by introducing Ulan. So, we are the largest B2B e-commerce platform in India. We have about 3 million active users, which are Kirana, your neighborhood grocery stores, pharmacies, fresh, lifestyle, you name it, right? We are present across 1,200 plus cities, and we do roughly about 5 million transactions per month. But the real, what excites me in introducing Ulan is typically I share my field experiences. So I was in Calcutta about 2-3 weeks ago in an area called Lilua. It's near Havra. So it's pretty much a small suburb of Calcutta. And we go on delivery runs, meet customers and whatnot. And some of the things that just, makes you feel proud, I'll just share one of those instances. So this is a small Kirana store. Probably, if I just walk, this is it. That's the storefront. We were there around 10:30, 11. It had crazy footfall, right? There was an elderly gentleman who manned the store, and constant stream of folks coming in, right? But now, what are the people buying there? I'm standing there. We were delivering our order, about 8,000 worth of items that we were delivering to this, what we call food FMCG store, right? A classic Kirana. And there are kids who have this small used fruity bottle, and they're 5 रुपए का oil दे दीजिए, right? 5 rupee oil. 2 rupee Parle G. 10 rupee Parle G. 1 eraser. So the average order value that is there per customer was less than 10 rupees, right? But that's real India for you. And it was just so, I would say, overwhelming for me to see the interaction. And when I asked this gentleman, how's your relationship with Ulan? How is it? And it was just amazing. It's like, I've been ordering from them, from you guys for a while. Pricing is good, selection is good, delivery is good, perfect. I have no complaints. I'm all sorted. Do you try anybody else? No. So these are the kind of the proud moments that you see when you see actually being able to impact lives, right? In retail, sourcing and being able to have all of those items is really the name of the game, right? You are retailing. So that's how Ulan affects the lives of so many people across India. And that's Ulan for you. So with that, let me introduce the data platform, right? And what better way to introduce the data platform that we built at Ulan with the scale. So this is a bit of a questionnaire. It's jumbled up order. If I may ask the audience, 1 petabyte, what could that be? That's an easy one. I cannot hear you guys. Sure, perfect. 800 terabytes? Correct. 20,000? Pretty good. Daily query runs. 2,500? That's the total number of dashboards that we have. 800? Data sources. 800 data sources and about 150 total data science DSML jobs that we run. Right? So that's, in some sense, the scale of the data platform that we operate at Ulan. Now, when we were designing the data platform, there were certain strategic objectives that we had, right? And I wanted to start with that. How did we think about data platform? So first and foremost, and in the previous question, I think you had asked from a gentleman from HDFC about data being in silos and in different places. So the first and foremost thing was ease of discovery and access, right? To break the data silo. It may seem like you have all the data, but quite literally, if you're not able to join the data across different sources, then it's not really available. So to be able to join, let's say, a terabyte scale data, which is the way the events are generated across the platform, and with, let's say, just returns data, which is probably post-order, it's even much smaller footprint per day. That's the power of actually true data democratization, right? To be able to use data across different sizes, scales, sources, and use them together. That's the power of data. Please pardon me, I'm recovering from dengue. Somehow, I don't know why, but my throat is very dry. The second bit is around the data fidelity, freshness, and reliability. When we say data platform, it's not a transactional system, right? Transactional systems are there, and we are making a true copy of the data and making it available for analytical purposes. So it's an analytical data platform. So that means that you need to be able to guarantee the fidelity and the freshness and reliability of your data, which means, let's say, if I said, I will update this data, I had mentioned 800 data sources. If I promised that the data will be refreshed as of every 10 minutes, I should be able to do that, and I should be able to promise that and keep that promise. So that's fidelity. Freshness of the data is also, again, tied to the timing and whatnot, right? So that's the second core objective. Third core objective, to do all of this in the most cost and resource efficient fashion possible, right? If you own the data platform or any of those systems, really you can throw money at it, but it's about doing this as efficiently as possible. Fourth being ease of data insights and streamlined MLOps. So once you have the data, you do something, for example, you want to take it to a dashboard, you want to run a job and actually deploy the system, for the platform to enable you to do that very, very efficiently. Otherwise, again, it's sort of a logged or a siloed thing that you built your best of the models, but you're not able to deploy it, or you're not able to see the benefit of it. And Varun was focusing a lot on the AI/ML deployment piece of it. So that's the fourth objective. And then the fifth objective, obviously, is governance and security, right? To make sure that the right people have the right access of the data. So these are the core strategic objectives, how we've thought about our data platform. And now, who are we solving for? Now, this is the audience part of it, right? When we build a data product, who's the audience who's using this product internally? And we think of it as three personas. The first is the obvious one, which is the engineers and the data scientists. These are the systemic workloads that you want to run, your AI/ML jobs that you want to run, to make sure that whatever data is required is easily accessible to the data scientists. I'm guessing a lot of you are data scientists in the audience, and you would understand the pain of not being able to get the right data at the right time with the right ease, and so on and so forth, right? So it's a real pain to actually get the data. Second persona is the business and operations team. So these are probably the largest footprint of folks in the organization, where they are the consumers, typically, the final consumers. They are the ones who are looking at a dashboard, reacting to it, or have an everyday task that is dependent on the dashboards or the data that is being published. And then the third being the analysts, who's actually both creating these dashboards, views for the business and operations teams, as well as doing the ad hoc analysis, slice, dice, whatever questions are being asked of the data. They are the ones who are sort of enabling that, right? So these are the three personas, the way we think about our data platform and who's the consumer of data platform, and having tools built for each of these personas. So in just quick summary, the the core features of the data platform that we built are structured this way. So we have first pillar, which is around the ML and data science tools for the DS audience, is to be able to deploy the entire model pipeline, right? So starting with your data, your EDA, to model iterations, to model deployment, to model monitoring, the entire life cycle of ML model deployment. Now, in those, some of the core components that are critical are essentially, for example, feature store. Feature store is one construct that we've sort of been very, very heavily relying on internally, that both helps in the data scientists being productive, cross-use across use cases very easily, then doing things at scale. How many of you have tried deploying data science models in user path with millisecond latencies? Quite a few. So you would understand the challenge and the pain that is, and the engineering that is required, right? To actually serve these DS models in production. And oftentimes they fail if the latency is not being met, then there is no, the engineering teams will not accept that as a solve. So feature store. Then you have your pipelines, which are actually the entire feature construction itself. How do you actually get the right data for your models? And then deploy. I already spoke about deploy, which is to be able to deploy these models in a scalable fashion, where all the monitoring, model monitoring, drift, all of those things are automatically logged, so that it's not, again, dependent on a single data scientist, right? So what we've realized over time is, as the systems mature or the systems age, you need to have these systems in place. Otherwise, it's very much dependent on one data scientist who would build this, and he's sort of forever logged into managing that model, right? So this sort of helps you to actually scale out and scale your ML production. Data management tools discover how to find data, what data is where, ingestion, which is to be able to get any type of data, structured, unstructured, terabyte a day scale, or just kilobyte a day scale data into one place. Business observability is another critical piece, where essentially a lot of the anomaly detection, that the core is anomaly detection, but what we'd want is essentially when things break. For example, GMB in a particular city in a category broke. What was the reason? Listings became unavailable. These things keep happening very often. And to be able to have that kind of business observability from systems perspective, data perspective, that helps significantly. And then you have a bunch of query tools, which is around, these are internal terminologies as well, probes to write the queries. Flows are the common data views that are reused across systems. Notebooks, obviously the Python tool of choice. And then segments. This is for the users who are not SQL savvy, and they just want to drag, drop, and get the answer. So that's a bit about the data platform at Ulan. Now, let me switch gears and talk about data science. Yeah? And I want to start with these two statistics around data science. According to VentureBeat, 87% of data science projects never make it to production. And according to Gartner, through 2022, only 15% of use cases leveraging AI and involving edge IoT will be successful. Now, I'm not sure how many of you were familiar with these stats, but for seasoned data scientists, I have seen my fair share of failures across my career, right? And this is real. I can relate to this. Now, how do we change this not so encouraging statistic estimate? And this is sort of my reflection or learning based on a bunch of things that we've tried at Udaan. Before that, I was with Flipkart, Accenture, IBM. So across the broad range of experience, this is how I have summarized my experience. Now, in order to get data science right, this is the Venn diagram. A lot of views are there. This is my rendition of how to get it right. The first part of it is the what and the why. If the business problem or the product need is not clear, right? You wish or you hope that there is some impact. That's first pillar for failure or first reason for failure. Or to flip it around, that needs to be correct or spot on very, very early on. This is, again, I have seen failures across all of these dimensions, so I'll not go into specifics for each of these, but getting the what and the why is this problem important from a prioritization perspective, from a focus perspective, all of that is clear. So before starting a project, if this is not clear, at least I walk away from it that let the product clarity emerge. Otherwise, there's no reason. We will just spend our cycles not going anywhere. The second bit is around engineering systems. You build your best model, but you have no way to deploy it. You didn't consider how is it going to get embedded in the workflow, in the business workflow that it is required to do. Let's take a fraud example. If you were to do a fraud check when an order is coming in, if you do not have a hook where when the order is getting placed to be able to check for fraud, then this, like you build the best fraud model, but that engineering system doesn't exist that is able to deploy this system, this DSML model. So engineering system is, again, extremely important and critical to, and you may co-build it, as Tarun was mentioning. You can co-build it, but at least having that understanding of where this module is going to fit in the entire business process is extremely critical. And if that is not there, again, the timing of the project might be premature. Third, obviously, is data, getting the right data. There was tons of discussion in the previous talk about data. What is right data, how much of it, etc., all of those are nuances. But again, having that clarity, whether you have the data to attack the problem statement, or you have a strategy or a path to get to the data is extremely critical. What I've seen is if any of these three don't exist, then come what may, we may try, but the impact is not there, right? And that's the impact piece. The fourth bit, which is often understated, is, to me at least, the most important aspect, is the people aspect. That you need people around this entire team that takes to succeed in deploying an AI/ML project, right? So people who understand the business problem statement are able to translate it from a business problem statement to a data science ML problem statement, understand what data needs to be gotten. So people across these three buckets as well, just doing their jobs as well. There is one other subtle aspect that is very important when you try to deploy, and I'll give an example from, let's say, the last mile deployments that we had. Whenever you are trying to deploy a model, one of the things is essentially, if it's a business process automation or an improvement, the person, the workflow where it is being embedded, that person feels threatened, often, more often than not. Last mile routing, as an example, right? So when we are deploying or trying to suggest, okay, here is the route that you should follow, and the person who's evaluating is the person who's actually doing it right now manually, that person is threatened in terms of, this is going to take my job. There is a much softer aspect, and I've seen this happen more often than not, that there are much softer aspects at play from a people perspective, where things fail because of this seemingly frictionful deployments. That the important thing is to structure the team such that you get the right feedback to iterate on the product, but also make sure that the change management or the software aspects are also handled. And that's where essentially then you see the impact. Yeah. So that's in a nutshell about data science and creating sustained differentiated impact from it. Very quickly on to the e-commerce landscape for data science, right? E-commerce is about sort of getting the sellers and the buyers. Here is a landscape of all the data science problem statements that exist in e-commerce, right? So starting with your catalog creation, how do we create it in the fastest possible fashion, make sure that it's accurate, that the attributes, this is a half t-shirt, not a full t-shirt, it's a collar t-shirt, and so on and so forth. Trust, fraud and abuse, that's sort of a core construct in e-commerce. Customer service, to be able to service the buyers in the most cost-efficient fashion. We have credit as well. Typically, each e-commerce companies now have credit. So what is the right underwriting? What's the right probability of default? Those kind of problem statements are there. Then you have your core problem statements around forecasting and planning. Obviously, this is retail, so you have to figure out exactly how much items to buy and the planning, inventory planning around that. Supply chain. Obviously, you have to deliver these goods, so those are complete companies unto themselves, starting with your first mile of pickup of the items to your last mile of delivery of items. Accounting, that doesn't have too much data science, but more analytics and data heavy. Then pricing, promotion, obviously pricing elasticity as a problem statement, promotion design, which products to put on promotion so that we make enough GMV as well as enough margin. Selection, design in terms of what is it that we should stock. FOS, that's a unique B2B construct, which is the feet on street or the sales force. How do you optimize that entire workforce for making them effective when they reach the buyers? And then last but not the least, one of the biggest bucket, which is discovery, right? You would understand search, recommendation, localization, advertising, all of that built into one. So that's, in a nutshell, a landscape of all data science problem statements in e-commerce. And the way I call it is data is the new electricity enabling e-commerce, right? It's no longer the oil, it's the electricity. It needs to be embedded in each and every function within e-commerce. With that, let me just go into very quickly one case study about search itself. So how we've used the XMC model to improve the search results. So what is the problem? So very often, buyers would use incorrect spellings, mistyped words, vocabulary gap, fancy pants. Examples are there. For example, Surf Excel, Boat smartwatch. So this is a very classic e-commerce problem statement. With the different kinds of buyer literacy levels, this is expected, right? Now, how do we solve for this core semantic search while maintaining low latency inference times? So inference is extremely important because this is supposed to be served in user path, right? You need to have just millisecond level latency. And essentially the solution, this is a KDD 21 paper called Extreme Multi-Label Learning for Semantic Matching in Product Search. That's what we've sort of implemented. The idea is extremely simple. You treat the query as something that you want to classify into labels. So the labels is the order of all the products that you have. So if you have 1 million catalog, you have 1 million labels. Once you get a query, you're trying to label it into one of these, multiple of these million catalog labels. That's as simple as that. Again, I'll repeat. Given a query, you want to classify it amongst 1,000,000 labels, which is the order of your catalog. Now, the intelligence is in how do you train. So you convert the query itself into its embedding using character bigrams. You convert each listing into its embeddings where you would want the similar listings to be closer together. And essentially, that's the basic setup. And once you have these vector representations of both the query and the listings, you're trying to figure out do this efficiently by converting it into a tree, doing a search across the tree to figure out which is the right label set, right? And the inference is first performed by first transforming a given query into a vector, and then searching the relevant listings in the tree top-down, in a top-down fashion. Because it's a tree structure that you are searching, it's log in the order of the number of listings you have in your catalog. So that's the solution. The impact, just qualitatively the results, before you would get a null search, with this, post this, you actually start finding Surf Excel, which is a pretty nasty spelling of Surf Excel. The impact, the conversion, essentially we've achieved about a 15% absolute improvement in the add to cart conversion, which is very significant impact. The null searches have been reduced by about 85%. That's another amazingly significant impact. And we've been able to serve these results in about 23 milliseconds median latency is with which we serve these results. Yeah, with that, that's the end of my talk. Thank you.